Welcome to a Thursday night. This is actually the second take on this video because I kind of really screwed up the first one. So I decided to really just cut a new one. Um, the first thing I wanted to show you was a fix in KDE Neon for the dialog box popping up on the wrong monitor all the time. So when I go to here, for example, and I'm in CircuitPython, and I say I want to open a folder, this was popping up over here on the third monitor all the time. Even though that monitor is not the main monitor, this one is, right? But it wasn't obeying. It was kept going up there. So the way you fix this is actually, I found out in a forum, is we go to system settings, like so, and we go and find what's known as window management, and then window rules. So you can see here I've created actually 3 rules already: file dialog fix open files, Visual Studio Code open the workspace one, and settings for various things. It's just the one I want to look at is just this one right here. So what you do in here is you open the dialog in question, put it where you want it. You then click the detect Windows property, right? Give it, of course, a description and stuff. Most of these things you don't have to touch, but you grab the position and size and put it in here, right? And then save the rule. And it should actually open the rule out. Now, there's one other spot in here that you have to remember. In Windows Behavior right here, under, I believe it's Advanced, turn off allow apps to remember position of their own windows. I find that that doesn't work. Okay. Some do it, most don't do it. So there's one other side rule you could put in each of these blocks, and it's in this one. Ignore requested geometry and force it. So that was in the cases of within Dolphin itself when I was opening certain dialogues within it. Or console, I think it was. No, I'm pretty sure it was Dolphin. And this stops that too. So once you have your rules set, after that, when you run here, I open file, or I say file, open workspace from file, it still opens up here. And I thought it was it's a hacky job fix, because you could always get a dialog box that doesn't fall under those 3 rules, and you'll have to create another rule. So just be wary of that, but it does fix this problem if you have multiple monitors. So next thing I found, I was messing around and just watching videos, and this guy from England was talking about the official Raspberry Pi Pico extension. So in Visual Studio Code, I'll change over here to the profiles, right? I created this profile, right? Raspberry Pi Pico. Okay, I copied it based off the CircuitPython one, right? And then I cut out a bunch of stuff I didn't need. Like I turned off extensions I didn't want, like the CircuitPython one itself, for example, because this extension deals with the actual Raspberry Pi SDK for the Pico. And as a bonus, there's a MicroPython manager too in there. So we'll change over to that profile, make it active. And notice now I have things like create Pico project. If you say create Pico project, it'll ask what style of project. I'm going to say C++. And it comes up with this. And it asks you what you want. Project name, what type of Pico, whether you're going to use, like if you're on the Pico 2, are you going to use the RISC cores? Where are you going to put it? Now, it's not obvious on this thing, but when you create, project test, for example, and I have here Home William Work RPI Pico projects. When I create this project, it'll be a folder called test. Okay? And that's what you have to watch out. And then you can turn on things in there. What do we want in our project? So I'm going to have a standard Pico here. This guy right here. And we're going to just make this just a Pico. So you notice we don't get the risk cores or anything like that. And console or USB. Now this one, I'm not quite 100% sure how to read it. I think this is more proper. I'm not using the USB for other USB anyway. Yeah, this is where the project name also is the folder name. When we say, oh yeah, you can turn on more stuff in here. Enable the CMake tool integration. Create. And you end up this project over here. Now, if I go to the File Explorer and I go RPI Pico here, there's test, and there's its folder. Now, I already have a couple of projects in here that we're going to use. So I'm just going to go File, close this. And I'm going to open an existing folder. RPI Pico, projects, Blink. Okay, this is your standard Blink program for the Pico. Okay, in C, not in CircuitPython or MicroPython. So you can see that by the include statement and stuff. So when we plug this in, and I got my cable here, and we hold down, so we go to the RPI boot slice. We plug it in, we let go. And we let go. One sec. Let's try that again. Apparently I didn't have the USB cable powered on. So, button down, plug it in again, and let go. So you see the RPI RP2? Just think I screwed it up. I was doing the MicroPython approach to this. Let me just run it and see what happens. Yeah, there we go. I didn't have to do all that. That was for the MicroPython. I'm a step ahead of myself here. But you can see here, blink, 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 blink. So this gives you all the Pico SDK in an environment in Visual Studio with a debug. Well, you can hook the debugger up. I don't have the pins on here. And it fully works with the debugger. It actually loaded that debug framework that it uses. Opens OCD. Da, 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 da. Just unplug it again. So that's the SDK side. I haven't done much more than just do what I've just done now. I'm still learning a bit about it. The other one that's apparent, if we close this off, and go back to here again. When we say create Pico project, we can actually do MicroPython. And I'll call this test 2. Okay. Now this is because this Pico right now has no MicroPython on it. We're going to fix that right now. That's the step I was doing last time that I shouldn't have done because I was ahead of myself. So if we unplug it and hold our button down and plug it back in and let go, it offers to install MicroPython. So we say yes. We don't have the Wi-Fi version in our hands, so we'll say no. This flashes firmware. So it's turning this Pico into a MicroPython based unit. And there you go. And it automatically connects. So next time you plug this thing in, like if I unplug it now, it's going to complain the connection's gone. If I plug it back in, it automatically connects again. Now on MicroPython, it's a little different than CircuitPython. So we're going to go and borrow our other code here. In this case, we'll close this folder, and we're going to go to open an existing one here. Close folder. There we go. And RPI Pico projects, Blink MicroPython. So this is a MicroPython Blink program. This environment is this guy right here. And I guess they bundled it together because it is actually technically another extension. You can actually see it in here. JKM there, Micro Pico. And then you scroll down some more and you'll see Raspberry Pi Pico. They actually are bundled together when you install them. Now, just like the CircuitPython extension with all its commands you can do, this one has also a bunch of commands. Right? Now, the code at the moment is not on here. It is on the PC. But you can still run it. See? Blink, blink. There we go. But unlike the CircuitPython where you just go in the REPL and you say Control-C, Control-D to restart it type idea, you don't do that in here. You should issue the stop command. So it stops the program. But let's say we want this program on there. Now this has a neat little thing. It can create a virtual file system to represent what's on the device. So if we click that, it's going to create one. Let's do it again. There we go. Sometimes I find when you toggle it on, it doesn't toggle on properly. So I think there's still a little bit of work and bug going on here. But we do note that he talks about this as it's experimental. So maybe later we'll get a better one. But you see that the virtual file system over here shows on the device there's no file. So we're going to put this file over there. So we can do that in our commands here. Upload file to Pico. Now it's in the virtual file system. I'm going to just turn off the virtual file system. Okay. And let's just unplug it and plug it back in and see what happens. I should be able to run it from the Pico itself, not from here. Run current file on the Pico. There we go. No, that's not quite right. That's this one right here. I haven't figured out everything yet about this. So your mileage is or kilometers will vary as much as mine on this if you try this out. In theory, I should have been able to just run it. I wonder, do I have a USB-C that's just strictly power here? I have so many cables here. A lot of short ones. Let's see. Cut it out over here. So this silver one. Nope, we don't want that one. That's actually connected to the computer. So we have this one here. Let's see. That one right here is no good because it's the wrong cable type. And this one here is the wrong cable type. This one here is really the wrong cable type. And this one here, yeah. No, I don't have one at the moment hooked up to there. So I'll just take this pinky cable. I have a brick underneath, basically a USB power source. That's if I can actually see the slot. That's right, backwards. So I have the file on the Pico, but it's not running. So I'm not sure what's going on there. Which one's the reset? This one? Yeah. So that's something I have to learn how to do. And put this back on here. And we're connected again. So that's where I'm left off. But it's a cool thing. I thought it was really interesting. I see it still has some more work to make it work. I mean, it could be simply just dropping the file on here. It's not like CircuitPython where it just runs it. So I'm not 100% sure on that. Yeah, well, we don't have Wi-Fi on here. So I have to figure that out. I have to do some reading on that. But that was my Visual Studio Code interesting plugin of the day. So file close. I don't need this folder anymore. Close source workspace. And don't save. Okay. So another project I was working on, I had to put the matters open thread matters to a side because I'm having trouble with the controller. I got up to the point where I have the web interface to pick the matter network and stuff like that, but it won't create a thread network. It shows an existing thread network, which I believe is that Google device over there, but it doesn't want to connect to it, and it doesn't want to create its own. So I have to figure out what's going on with that. So I had this panel for quite a long time. As you can see, it's just these matrices of 8x8s all glued together into a big board. And you can see it has all the chips and everything. There's an in and an out, just like the Hub 75 panels. Like this one here. They even look identical, but they are not identical. Hub 8 and Hub 75 do different things. Now, I'm pretty sure that this guy here is actually two colors. I think it's red and green, although I'm only using the red side at the moment. Right? I mean, in theory, I could unplug the red, the R1, and put it on G1 and see what happens. And we might just do that for a sec. Now, the only code I found for this was, and I don't have it on this machine, I have it over there, was an Arduino project from a little while back from some guy. And it was in 3 chunks. Chunk 1 was called Ron Animation, and it's the one that does all the letters across it. And if I just find a appropriate thing to plug it in, like so. So it actually works really good, as you can see. Problem was, it was only specifically for 3 Arduinos because of the 2 other packages in there. There was a second package, library stuff in there in the whole overall project. It was called Hub 08 SPI, and I believe that's the communications stuff to handle the talking. And then there was a third one called Timer, and from my understanding, it's a very old library in the Arduino, and it's being replaced by newer versions of it that's more versatile. But this was all coded around those 2, and the result is the timer piece only compiles against nanos, unos, megas. That's it. If I took this guy here and I turned it into Arduino, it wouldn't compile. It came up with weird errors in the timer module. Now, the other thing, a problem with this, of course, is you want something on here, it's all fixed. And of course, as you know, a nano, an uno, stock nano, stock uno, and stock megas don't have Wi-Fi. So it doesn't matter which board I put it on, I can't make it dynamic. I really need a Wi-Fi connection so that I can actually go out. And I was working on that problem. Let's see if I could do this. I did really like that Ron animation thing in here. Right? It would be nice. It would be neat if I can find it. That it was a CircuitPython program. So this is the Hub 08 running, and actually, it's pretty slick. Like, I mean, it's all smooth, and it's weird too. I had this on the Uno, and up here in the corner, you would see flickering lights in certain other spots where the LEDs were flickering. Now, the other thing I haven't done on this panel is technically there's a layer of protective plastic on some of these still. But otherwise, it works really well. So that was that one. So I put it aside. And we come to this one. Well, actually, technically, we come to this first. Now, this is the Citron board breakout. You can put any sort of Pico on here, right? And what it does is it has a ESP32-01, this little guy right here. So you can choose to plug it in or not. And it uses 4 of the 8 pins. So it uses the ground, it uses the voltage, and it uses GP16 and 17. And for some reason, it actually uses 2 voltages, but so there is no flow control or anything on this guy. And what you're supposed to do is use ESP control, I think it's called, to talk to it in CircuitPython. My problem is I got it running to the point where I finally was able to talk to this, and that only was because I found I had to actually flash firmware on here. And the first time I did the firmware flash, I just used a breadboard to cross match the wires and stuff like that from one of these guys. This is just a USB to TTL with a CH340 chip on it. And yeah, sure enough, I flashed the Citron, but I had an issue. When I issued the AT commands to this to connect it, it said it connected, it shows up in the repo, blah, blah, blah. And then it starts issuing AT commands to do things, and they all aired out. So at first I thought the firmware wasn't right. So I dug around and flashed a few other ESP32 firmwares for these guys, including the one from Expressive. And it turns out the firmware that Citron had was for an ESP3201S. And the only difference between the S and the non-S is that the S has more flash storage in here. And effectively, this is an 8266 Expressive in here, ESP 8266. So, and it's really bare bones. There's just barely enough on here to actually run the Wi-Fi, basically. So the only thing I'm thinking that might be happening is when I flash Citron's firmware onto this one, the non-S, it got cut off. That things aren't all there properly. I don't 100% know. It's very hard to find samples of it flashing that. There are people out there flashing, but they're all flashing the S version, not the non-S version. So I ordered from AliExpress a batch of S's plus a couple of pre-done programmers just for these guys. So I'll eventually have O1s and O1S's. Now I made my own programmer. So I just used a board here. Now one thing I did screw up on the board, but it doesn't matter for the flashing purposes. That piece right here where I jumper this guy should be in the middle, because this jumper selects whether you're flashing with 3.3 volts or 5 volts. And I rigged it, I think, for 5 volts, which is what it really needs. So that's why it works. But I should fix this thing one time. So this, I plug it in, I flash it. So now I have my own little flashing tool, but of course it didn't work. So I said, okay, if that's not going to work and I'm having trouble and I have to wait for the other ones, put this aside. And the programmer, and let's go to standard ESP32S3 with the Wi-Fi chip and everything on it, and do it from there. Wow, okay, that opened a barrel of monkey problems, because in the code on this thing, and I think I can show you on this particular one. Let's see, plug it in. And if we go over here and we change over to CircuitPython, now, of course, I have to figure out which CircuitPython I'm on. Where's my File Explorer? I lost my File Explorer. Let's open it up again. I think it's the second one here. I'm going to go up here, and did I have a workspace in there? Can't remember. Yes, I did. Yes, Lolan S3 workspace, so I got the right one. So let's go open the workspace. This CircuitPy, this workspace, open it up. As you can see, here we go. Sorry, wrong screen. As you can see in the thing, I add many codes here. Problems one, what is it? Max 7219. I thought I had that already in there. What happens when you get these warnings in this plugin? It's because one of its control files, mainly setting JSON, it's got the wrong date in it again. It sometimes updates, sometimes this is a bug that the guy who makes this got to fix one of these years. So it's 2024 11/14, and you can see I've got 11/10 in here. So if I go here and I go 4 and Control S, problem goes away, right? Now you might wonder, well, William, you have a workspace file also. True, I do, and the workspace file is up to date. Why isn't it overriding the settings JSON? That's a problem he has to fix. I don't think it's supposed to be using the settings JSON once you generate a workspace file. So, side bug. So if we look at, let's see, code 2, code 1, I think it was code 1. This is where I was testing out the display. Code 2. A different way of testing out the display. This is a more modern one. This one, what am I? Yeah. My elbow was hitting the pad. So this one was the older test code. And this one was a newer test code. And then code 3 was, this was stolen from this was the actual Citron code. And I've been now starting to get in the habit, because I keep needing to know what the pins actually are on the board. So one of the first things I've been doing is going into the REPL. And going import board, dir board, and then cut and paste it into the file as a comment, so that I knew which what the pins were, without having to go do this all over again. So this one here, you can see in here, we got Adafruit request. There it is, ESP AT control. So this is what Citron was using to talk to that little ESP32. And you can see here the 2 pin numbers, blah, blah, blah. And their idea of doing this, and I think, where was their code for opening? I think I now have it in this one. Let's see, that was 3. Let's go to code 5. Yeah, and I would have to get the code from the other machine, the exact code from Citron. But basically, they would invoke the ESP AT control lib, and they try to talk to it, and then they would come back and get the time and query the time and stuff like this. That's where that time API is. You define it as the site you're going to go to. Yeah, see ESP Adafruit ESP control, blah, 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 at what speed. If this ran and it was on that board, it would spit out connections and stuff like that, but then it would just stop working because the AT commands would come back all of error, 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 all of them, which they're not supposed to do. So I was messing, okay, so what if I use Adafruit's Wi-Fi? So Adafruit had a, let's see, code 5. So this was, this code here, I'll just shrink this a little bit. This code here was the updated Adafruit, and I added a couple of things into here. So Adafruit sets all these guys up. I actually added the time API because I was messing in this code with both NTP and time. And then Adafruit would come along. It would list all the network things. And I think this code here, yeah, this one has it too. And if we go control down here, D, see all the zones come up. It connects. But in this particular set of code, when I hit my debug statement 1 here, the rest of this is not working. So this was the code from the Citron. I borrowed the whole while section from their code. I wanted to check out this. But it seems that when I request time from the time API URL, it only works 1 in like 10 tries. Otherwise, it just keeps erroring out. And there is a flood control on their side saying you can't do this so many times. So I decided, well, could I not just do NTP instead? Now, you might be wondering where this came from. I actually got it to work a couple of times, and when I did, I cut and pasted this string out. So I could fake out a response. That's why I remmed out the response, and I gave the response what it was, and then let the rest of the code. But it doesn't work in here. It just, something's not right. And I haven't figured out what it is. And that's all their code. Now this stuff here was to demonstrate, and this is taken out of another Adafruit program. This works. I just have it remmed out basically. But it actually knows how to stream all the text across here. So, and that's where I was working on this. Now, my puzzling thing about this whole thing is they embed how they connect to the Wi-Fi in here so deeply, and they just sugarcoat it basically, so that you don't see what's actually happening. Unlike the other one, where you actually see the AT commands being issued to the Wi-Fi chip in here and blah, blah, blah. This one buries it in something. So here's this Wi-Fi class, radio, start scanning, right? But how it knows that what this Wi-Fi is and what pins they are on and stuff like this, don't know. So in theory, if I could figure that out, I should be able to use the ESP-AT controls on this one, right? And talk to the Wi-Fi in there. I think. I see no reason why I can't, right? So that was what I was working on this one as a project. And then I had another side when I went back to look at some more, and that was the weather gizmo. So I'm going to just close this off. Close workspace off. And I will free it from the file system so I can... Oh yeah, by the way, over on the VM, I must have had to reset a few controllers right down to redoing the file system on it, because it was flip-flopping between write protect on, write protect off. So it would flip into write protect on, and then also you can't save anything, of course, to the drive. And then the drive would say it was corrupt, and oh man, it was just real annoying. It wasn't happening over here, just on the VM. And my suspicions is in VMware over there, I upgraded it to the 17.6.1 or whatever, the new free version. I regret it. I should have left it at the 17.5 version, the last paid version. And I might roll it back, right? Because there's obviously something going snarky over there. But I did get the controllers working again. At first it was just write the firmware again, drop the UF2 file. But then I got more cruder, and I went and backed up the files off the things. You can still read it. Then I did a MKFS.FAT on the thing and wrote a new FAT file system. Then DOS label to write the CircuitPy label to the drive and set it up. And then put all the files back on. right? Just paste them back on. And then the controller seems to be working fine again. So I'm not 100% sure what's going on over there. But anyway, I have to safely remove this and put this over here. So this was broken for quite a while. The reason it was broken is the people who put out the API for the weather. You used to just have to have a free account and generate a what do they call those IDs? Access tokens, and you could access the API for nothing for a hobbyist, right? Then they took that away and made it a pay model. I would add a sign up, create an account, sign my credit card to it, even though I wasn't going to be billed for anything, which I found stupid, and then just to get that. But someone else came up with an open API for this, and there was new code on Adafruit. If you go to Adafruit's site for this mag tag for the weather program, and you go to where the code is, they will talk about not only changing the code block, but also using the open weather API, and also using the new settings.toml file instead of the old secrets file. So once you do all the fixes in here, right, and put the new code in and stuff like that, you get this. But notice something interesting on this side, on the future. It doesn't do future to 5 days. It only does future to 4 days. Because under the open weather API, it gives you 5 days of weather. 1, 2, 3, 4, 5. In the older one, it was current day, and then 1, 2, 3, 4, 5 days. That's the only visual difference you'll see in the thing. And I can say right now, this is stupid. There's an error right there. Minus 0 Celsius. It should just read 0 Celsius. I wonder where. I would have to go look in the code where they do the AM, day, and PM times, right? And find out why they're putting a negative on this negative 0. That's not a math thing. But that fixes this thing. And now I have my weather thing back, and then I just stuck it over here on the computer. It's got those magnetic legs on it, so it can do that. So that was that one. I really would like to get back to the Matters one, but I need to figure out from Expressive what's going on. Now, they do have a Discord channel, so I might have to dip into there and ask what's going on with that code. Maybe they even fixed it. I don't know. But I think when I looked at Git last time for that code, it was a bit dated. It was a few months old. So I don't know if anyone's been working on it or not. And I don't know why that I'm getting 404 errors out of the built-in web server. So I shouldn't be. But that was that. Anything else that was of interest I was working on? No, just by sorting crap out, losing track of things. Oh yeah, these guys. I have these very expensive Titanos from thing. So this particular one is the original one I had. I had to replace the reset button because it actually arrived with the reset button ripped off. So it was not on properly. So I fixed it. Although my button is a little on the high side here. See? And then I couldn't find this. I was missing it for the longest time. So I bought another one. And you can see here where the button's much thinner. So I have this new one, right, compared to this old one. And then, like anything else that happens, I found the old one. Now, I would say that if I was to rebuild this thing at Adafruit, first thing I would do over here, these type of connectors, I would change them over to the smaller GS13 ones. Instead of these really big ones. Because now you have to have conversion cables for all these. But I did find them. And then I found my Scorpios, and I haven't. Those are those Adafruit feathers with the controls 8 rows of LEDs. Except in my case, it's not controlling 8 rows of LEDs. Here, let me get that. I have it over here. So I was messing with this one. It seems like every time I start one of these, I run into problems. So we have 2 panels hooked up. And I was testing against this port right here. So this is the Adafruit Scorpio. So these guys here can control, they're labeled basically 0 through 7. And they control up to 8 strips. Now, you might be saying, well, this is not a strip. This is a matrix. Well, in essence, it is a strip. Because the way these LEDs are connected on here, it goes like this. Like a snake. Back and forth. So it's actually a chain of 64 neopixels in a row. And this one here is hooked onto the ports, and this one here is hooked onto just a data pin and here over here. So this one is being driven by the NeoPixel library, and this one's being driven by NeoPixel 8 library. If I put it on, you can see this one over here is changing colors. Red, green, blue, red, green, blue. This one here is just sneaking through, and it's supposed to be a rainbow color. The only color it displays is red. So if I open up this CircuitPy, yeah, there it is. I'll open Workspace. And we will open up one. So we open up CodePy. We'll open up a terminal. Notice the 6 problems here. That's just as I said, because this guy here is not 14. This file doesn't always get updated properly. Problem goes away. So there's your NeoPixel 8, and there's the regular NeoPixel. So I define the regular NeoPixel on D13 right here for this panel. And then for the one that's snaking right now, this is what it's supposed to do. It's supposed to be running this comment class. Rainbow color wheel. And I've run the rainbow color wheel before on matrices, right? But it doesn't do it. So I'm not sure if I've encountered a bug in the code or the sample doesn't work. Now, I've run the sample as completely purely their sample without the NeoPixel. Well, a variant of this file anyway, without my troubleshooting stuff in it. And it doesn't work. This thing just cycles back and forth red only. Doesn't matter what port I put it on or whatever, it just does red. And as far as I can figure out, it's in here. And yeah, so I can go here to this part right here, and I can rem it out, and this would stop this panel. Or I can make this panel a lot faster than the snake. The thing is, the snake is moving a little slow because it goes through the snake once, and then it goes through this. Then it goes through the snake once, and it goes through this. So having the debug ahead of the snake slows it down. But it doesn't work. So strictly red on here, and these are the same panels. See? So go figure. Now, I thought possibly maybe it's a ground issue too. I was just thinking about that. But it's not occurring on this one, and it's just sharing the same ground. Now, according to this, the inner row here is the control, and the outer row here is all ground. So, in theory, I can unplug that into there and plug it into here. Yeah, see? Same ground. So that's what I was working on a couple days ago. And I was also prepping the VM machine over there to start work on. I wanted to experiment with Bitto, and I want to experiment with the camera server code. So let me close this off. Close workspace before I break something. Safely remove. There we go. So I was wanting to mess with the ESP32 cams, and if I go into projects, oh, I need to change this to platform IO. And if we go and open projects, platform IO, and we look for camera web server. So this is the Arduino project for the camera server. It's in 4 files. So this is the web server. Define the camera pins in here. So when you actually open up that web server part, here, let me just juggle. We don't need partitions, and we don't need platform IO. Camera index, camera pins, past index. So when we're in here in the app, right? Now, the other thing I have to do, I need to do the modifications from another guy that changes where the Wi-Fi is done in here. Just a second. It's a good thing I didn't do anything yet. Here. Okay, I think I'm ready now. So this guy defines the camera model. So the camera model is basically the AI thinker. Do I have one here? These things. So what we're playing with is any of these guys basically, but I happen to have over there 2 of them, and they actually have the daughter board on them. Now in theory I have a version in here, this one, right, that actually has the interface thing on it. Now the problem I found on these, I think this one's a good one, and this one's a good one. I have another one that's broken because when they put this on here, up here, they didn't solder very well. And I wasn't using these because I forgot that it doesn't have a, I need to tape this down. So, and they actually have different cameras on them. You can see this in this one here, but tilted at an angle, you can see that they're actually different cameras. This one's a different one than this one. And I actually have in a storage bin a lot more of them. So, including this funky one, the Liligo, I think it is. The idea of this is goes on here, like so. Now, this guy here, if I'm not mistaken, is rigged against... can't remember. The problem, of course, they stick this damn shit on here, and you can't read the chips underneath. Yeah, there's an ESP under here, and I think it's not the ESP 8266. I think it's the S3 or something like that. I won't know until I actually really, really decide to use this one. But, oops, that goes in here. That's the battery connector. So if we go back to the code, I'm not going to scroll this screen because I happen to have my Wi-Fi creds in here. This is why I want to move them out of here and read a file, kind of like reading a secrets file instead of embedding it in here. But when you pick this define here and you come back to camera pins and you scroll down, there's the camera pins for the AI thinker. So yeah, I can convert some of the stuff into CircuitPython, right? It wouldn't be hard to do. And then the problem is this particular block, this whole web server that's in here. And it's a big file. We're talking, I think, 1,100 lines of code here. No, sorry, even bigger. 1327 codes, 1,327 lines of code in here that have to be turned into a CircuitPython version of the same web service. Right? So this is running in there, it receives requests. This guy here controls the camera and gives all the options in the web server. And this guy here, it's like the control code for the cameras themselves, all in a big, stupid long index string, as you can see. You can see on the side there here, it's massive. Like one camera is, as you can see, is 268 lines. It's probably what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 19 per line at, 265 lines, basically, if we're not including brackets and stuff, per camera. So this file's full of these, has at least 3 cameras in it. And that would have to be converted. So I would need the CircuitPython equivalent of this file to control the cameras. And I think they exist on CircuitPython. I think there's what they call boilerplate libs that you can include. So you would include, camera OV2640 as a library, and in it would be this stuff all set up. But you wouldn't have to worry about that. So this is where I wanted to do the AI stuff, and if it can help me convert this over into, we'll get the frameworks and stuff, and then I can start gluing pieces in. And I think this just makes sure that when you're building this thing, you're not building for these 3 units. I suspect too that even though this is for the AI thinker, if you actually look at the camera index, no, not the camera pins. No, let's say camera web server. See, you got all these. There's the 32 ESPI and S3I, for example, are in here. S2 camera board. Zhao, that one is those tiny little square guys. Um, TTGO, I don't think I have this one, but I believe I have a couple of these. I did finally get a hold of ESPI, mainly I think the ESP32S3I, right? But that's where I'm on this project is to try code conversion. And in the case of this, you can see over here, I actually don't have it correctly in. I think I had turned it off because it was prompting me all the time. So this is Bitto. And I haven't set it up, of course, in here, but basically what they're after is to log you in into the Bitto website and stuff. And once you do that, you only have to really do it once. Then it supposedly works, and then you'll get a panel here, and you can ask it questions of the open code window, stuff like that. And that's what I was working on here. Yep. Otherwise, for this couple of months, I'm going to be very bored for some certain reasons. I can only sit down and do this stuff for so long. I'm just getting a little old for it. Probably my brain is going to turn into fudge, and that'll be it. So this was it. This is what I've been working on. If any of these little pieces you want more detail on, just ask. I'm sure I can make another vid with more detail on a particular part. So I will call it here.